So now the horizontal wind over the sea surface acts as a frictional force, and it wants to drag the water particles in the same direction as the wind. Okay, and a little sketch here looking from the side how it looks like. It's a horizontal wind. It is the frictional force, and shows some structure in the ocean currents. Okay, it's called the frictional boundary layers. And you will learn later on that under the influence of the Earth rotation, what happens is that the wind frictional force actually creates something that we call the Ekman layer. And the currents in the Ekman layer are actually not in the same direction as the wind. Okay, but more about this in later lectures. Okay. So the magnitude of the wind stress, that's the name of this frictional force. The frictional force is actually proportional to the square of the wind speed. Okay, it's a little formula. And in this formula, you see something like a W, and the W is the wind speed, and usually what we use is 10 meters above the sea surface. The wind speed in meters per second. And then there is a conversion into the frictional units. There's the air density in there, and there's something that we call a wind drag coefficient. And you can look up the numbers, the values for these coefficients. So the important detail of that is it's a nonlinear relationship between the wind speed and the wind stress. So the greater the wind speed, the even more greater is the wind stress. Okay, and I'll show you a little graph created with Excel at the bottom, where it relates the wind speed in meters per second to the wind stress, which has units of Pascal. All right.